If I create a video because of your comment, I'll give you a shout out. So be sure to let me know in the comments what you'd like to see.
Alright, so my video today is based on a comment, partly on a comment from Mr. One Shot Away, who asked that I do a video on color sensors. It just so happens that the college that I work for has recently asked me to work on a robot that they have, and they wanted to get some code running, and it has a color sensor, so I figured it was a perfect time. Before I get started, I just wanted to cover a few things. I'm not going to use the Arduino IDE for this, just because I think it's a little faster for me to write code in the IDE that I'm used to using, and personally, I'm not a fan of the Arduino IDE. If you do want to use this IDE, I will be making a video on how to set this up. So you can use this IDE or technically any IDE for that matter, but just so that you know, this is not the Arduino IDE. However, the code will all be pretty much the same. The color sensor that I'm going to be using is a TCS230. It's the same as a TCS3200, a TCS2300. Basically, most of the sensors that say TCS are going to be the same. So I want to do this in a few different parts. Part one is to learn a little bit about the sensor. Part two is going to be to write your own program for the sensor. And then I did find a library for the sensor. It did seem a little difficult to use. The documentation was a little confusing. I understood it, but I'm pretty sure that somebody who's just getting into Arduino isn't going to really understand it. So I will show a simple way of how to hook up that library if you do want to use it. But mainly this video is going to be covering how to write your own code. So the first thing I usually do when I want to use a sensor, and I'm not necessarily going to go straight to using a library, is I'd want to look up the information on that sensor so that I understand how it works. Okay, so again, I'm using the TCS230, so I just look up datasheet. Okay, and usually the first thing that comes up is going to be you look for these little brackets that say PDF. That's going to jump right to a PDF controller or a PDF document with the data for that sensor. So now there's a lot of information in here. You don't necessarily need to read it all. What I'm mainly interested in is the outputs, what those outputs do, the operating voltage and stuff like that. So I can see right off the bat here it communicates directly with a microcontroller. It has single supply operation, 2.7 to 5.5. So basically I'll provide a 5 volt signal, but it could work at a 3.3 volt signal. It's a high resolution conversion of light intensity to frequency. So basically what that's saying is that as light intensity increases, it's going to convert that intensity to a frequency. There's going to be a signal that comes out, and you can see that here. The output is a square wave with a 50% duty cycle with a frequency directly proportional to light intensity. So the higher the light, the faster the frequency will be. The lower the light, the lower the frequency. So now we kind of understand what that means. This one's important. Output enable. This places the output into a high impedance state for multiple unit sharing of microcontroller input line. Now I did a little pre-research on this so that I didn't have to read it all in front of the video. Basically, if you want to hook up multiple sensors to the same digital pin, you can't have them all outputting the signal at the same time. So what this allows you to do is allows you to safely disable this color sensor so that you can output a signal from another color sensor. I'm not going to be going through that here, so this is just sort of informational. This one in particular converts an 8 by 8 array. There are other sizes, but you can see that here there's an 8 by 8. I think there's a 4 by 4. There's 16 by 16. Basically what it says is that there's 16 photodiodes have blue filters, 16 have green, and 16 have red, and then 16 are clear with no filters. So what that's saying is that in this grid there are green, red, blue, and clear or no filter to detect the different components of light. So, and then the other thing too that's interesting is that they're interdigitated, which just basically means that they're not, you don't have a block of red sensors up here, a green sensors over here. They're all kind of intermingled with each other so that you get a nice even reading. Here's a block diagram showing that you have light coming into a photodiode array that gets converted to frequency, and then your output is a square wave at 50% duty cycle. And just to clarify, 50% duty cycle just means that your signal is going to be on for half the time and off for half the time. So if you wanted to just use one pulse or half of the cycle, you could just double it because you know that it's a 50% duty cycle. And that's basically what I'm going to be doing. Some other things here that are important on data sheets, you have the pinouts, so that tells you what all the pins are doing and what they're for. So ground, output enable, which I mentioned already. The output, S0 and S1 are the output frequency scaling. That's down here. It gives you the options that you can have for output frequency scaling. Basically, if you have those two pins as a low, it's going to be powered off. A low high, you're going to get 2% of the frequency rate. High low, you're going to get 20%, and then high high 100%. I'm not going to mess with these. I'm just going to go straight to high high 100%. And then you have S2, S3, which is the photodiode type selection inputs. So this is how you would determine whether or not you're going to read from the red, the blue, the green, or the clear. So depending on what color you're detecting, you would change this configuration. Not really a whole lot of other information in here that's going to be pertinent for this video. A lot of this is more advanced stuff, but basically just gives you the minimum, maximum outputs, inputs, and what you should be watching out for. And then usually there's some information about the spectral intensities for light sensors and LEDs and stuff like that. And so it's just nice to know because you can see that there's some overlap over some of these. So you know that blue and green there's going to be a point at which they can both be the same frequency. And then some considerations for hooking up power supply lines decoupled by capacitor and stuff like that. And then there's a PCB printout and then some diagrams. So there's a lot of information here. Most of the most important stuff is up at the top. You want to read the description so you fully understand what you're getting into. And then you want to read the pinouts to understand what all the pins do and which ones need to be hooked up. So in my case, I'm going to be hooking up the ground, the VDD, which is the supply voltage, S0, S1, S2, and S3, and then out. I'm not going to bother with OE because that one, I'm only using one sensor and it's defaulted to allow the output for this sensor. Okay, so with that, let's get started. First off, I'm going to set up my pins. So we'll do that there. And you can use a define, which is a preprocessor directive, or you can use const. I'll just use const just because it's keeping with the code aspect of this. It'll make sure that you're using variable types that are still valid. And it'll be doing type checks and stuff like that. So in general, if you're just getting started, it might be better not to bother with defines, but I will be using them in a little bit. So anyway, getting started. I have my S0 hooked up to pin 0. And then I'm just going to copy this and edit. So I have S1, S2, S3, and then my output. So we have S1, S2, S3, and we'll call this out. All right, so now that we've got that, we do need a variable. We'll create a global variable to hold the values of the red, green, and blue components when I take a reading. And you could create 3 different variables, but this is kind of an opportune time to use an array. So if I wanted to use 3 variables, I would just do int red equals 0. Always initialize your variables. However, I'm going to be using an array. So what that is it's going to be basically three variables, and I'll be able to use one variable name to reference 3 different variable values. So I'll call this variable RGB values. We need a bracket to tell it how many variables we're going to store in this array. We want to store 3, and you can initialize arrays, and the way to do that, to initialize all the values to 0, is to set your declaration equal to open and close curly braces, and that will set those 3 values to 0. I always encourage people to initialize your variables so that you have something and you know what's in that variable when you start the code. If I don't initialize these variables, they could be any value. You don't know what they are because they're using a location in memory that might have been used by some other piece of code, and it's not cleared out before you get to use it. All right, so now we're set up with our global variables, and now we'll turn on the sensor and we'll set up our pins. So set up pin modes. So I'm going to set up my pin modes, and when I do that, so pin mode, color sensor S0, and that's going to be an output because we're going to drive a value out of that digital pin to our sensor. And then I'll just copy these over, S0, 1, 2, 3, and our output. And now our output is actually an output from the sensor to our microcontroller. So we need to change that one. That one's going to be an input. So our color out is our input to our microcontroller. And then this one just becomes a 3, 2, 1. Okay, so that's pin modes all set up. Now I want to set the frequency mode. Remember there's 0 or off, 2%, 20%, or 100%, and 100% was to write digital high to both. So digital write S0, high. Copy that there and put this to S1. So set frequency scale to 100%. And you should always use comments just to make your code a little bit more clear. All right, and what I want to do is, now I will mention, usually sensors have a startup time. It does mention in the datasheet that there's, I believe, 100 microseconds between when you power it on and when you can read. I just like to put a delay here, just a half-second delay. But that's just my personal preference. You probably don't need it. So the next step, I've got it turned on. I've got my pin modes all set up, and I just need to take a reading. So I could write this in the loop, but what I'm going to do is create a function. And when I call that function, it's going to read the color sensor, store the values in the RGB values array. And what this is telling me here is that I have not declared a function with this name, so I will tell it to just create a new one for me. I don't have any return type. Okay. Obviously, first I need to set it to one of the filters, one of the red, green, blue, or clear filters. Okay, so we'll start with red just because it's simpler that way. So we'll call this read red, and then we'll have one read blue, green, RGB, and then read blue. And I don't really care about the clear. I'm not looking for intensity. I want the components of the color sensor. So we can refer back to our data sheet here to look. So red is LL. So I'm going to digital write. I'm not sure why that's not. Digital write. Color sensor S2 to low. And then we'll do the other one. Same thing. S3 to low. Okay, so now I've set my filter. And I need to store the value of the signal. So RGB values. I want to refer to the first element. And I'm going to use a function called pulse in. I'm not a big fan of pulse in because it can basically halt your code for a period of time if you're not getting a valid input signal. For the purposes of this, though, I'm going to use it just because it's the simplest without getting into some more advanced capabilities. The library I will show you later does actually use a frequency counter, so it's not limited to that pulse, the pulse in. So pulse in, and nice thing about my IDE is it tells me what variables. So the pin that I want to read, that's going to be the color out. And then the state that I want to read, so in my case I'll just read high. And basically what that's saying is that when I call pulse in, it's going to wait for the signal to go high. Once it goes high, it's going to count until it goes low. When it goes low, it's going to say how long was that, and then it's going to return with a value. Now, what I was saying was pulse in, if it doesn't ever go high, it's just going to sit there waiting for up to the default, which we just saw that here, up to the timeout value, which is defaulted to 1 million. I'm assuming that's microseconds. I'm not positive, but that's going to be 1 second. So there could be a whole second delay in your code if you're not getting a valid signal from this color sensor. We could obviously change that by adding the other argument, but we'll leave it as is. Okay, so now I've read my RGB values. One thing I don't like to do when I write code is I don't like to necessarily use static values like this, like 0, because we don't really know what that means. What's RGB value 0? So what I'm going to do is I'm going to call this red. And it's yelling at me because I don't have anything named red. So I can create a global variable, a local variable, a macro or parameter. What I'm going to use is I'm going to use define. Okay, so again, this is kind of a way of creating a constant. It's not exactly the same. So don't trust a define statement to always be accurate in your code. But for the purposes of this, it's pretty simple. I'm going to say that red is position 0. Green, that's position 1. Oops, this is not right. And then blue, which is position 2. Now the thing with arrays is that they start at 0. So if we have 3 elements, it's 0, 1, and 2. That's the first element is 0, the second element is 1, and the third element is 2. So it's a little confusing, but you get the hang of it after a while. And basically what happens, just to clarify on this point, with a define statement, what essentially happens is as you compile the code, you can think of it as like a find and replace. And basically, it's going to find anywhere where you reference this word red, and it's going to replace it. So it is technically kind of the same as me writing a 0, but when I look at the code, it's a lot more readable when I see a red. So the nice thing about the define is it's not stored in memory, so it doesn't take up memory space, whereas a constant would take up memory space. But a constant also has a type, so it's useful to use constants because it will make sure that your types are accurate, whereas defines are not. So since this is basically the same code, I will just copy that here. And for blue, or green, sorry, we have high, high. So we'll just set this to high, high, and then we'll say green. And then same thing, we're going to read the same output with the same, we're looking for a high signal, and that's going to be our green. And then we'll do the same thing for blue. Blue is going to be low and high. So we will just simply set that to high, and then we'll change this to blue. Okay. Now, let's see, color sensor. So this should read our color sensor. It's going to store the values in there. And now I just need to create something to display the readings. Oops. Display color sensor. Oops. Readings. All right. In order to do that, obviously I need to set up my serial output. Set up serial monitor. Serial.begin. With the baud rate, I like to use 115/200. I won't get into details, but basically it writes to the monitor faster. So now what I'll do is serial.print, and I'll print, I'm going to do this all on one line, so I'm going to print the RGB values all on one line. And what I'll do is I'll just say RGB intensity and now because I use a print, it's going to print but keep the cursor on the same line. It's not going to move to a new line. So now I'll be writing at the end of this with my variable value, which is going to be RGB values red. And then dot print, and we'll print the spacer that goes in between. And then same thing with blue. Actually, I'll just copy this because it's faster. I don't want to waste your time here. But that's going to be blue, and that's going to be green, but we don't need that last one. So we have red, and then it prints a bar. Then green, it prints a bar. and then blue, and it doesn't print a bar. But since we're done, we can print LN, and that will move the cursor to the next line in the serial monitor. All right, I think that's about it. One thing you might want to do is, just for the purposes of, since this is a test, I'm not a fan of using delays in your loop, but because this is a test and I don't want to be spewing out data to the serial monitor at super high rates, I'll just put a small delay between readings. So that way it'll take a reading every second. One thing that might be nice to do is it might be nice to add in one more thing. Maybe we'll put in here serial.print and a hyphen, and then print out what color we see. So detect the color component, or primary color component, we'll call it. And basically what that's going to do is we're going to say if RGB values, if red is greater than RGB values blue, and RGB values red is greater than RGB values green, then we know that we're seeing predominantly red in our components. So we'll do a serial.println red. All right, and then so otherwise we have, and we can just take the same condition, else if, and we'll just change this to, now we'll check for green. Okay, so I'll copy that. If green is more than that, and then we change that to red. Okay, so if green is greater than blue and green is greater than red, then we see green. So we'll print out green. And then same thing. We'll just change this to blue. If blue is greater than green and blue is greater than red. So now I will do a serial.print, print ln, sorry, of blue. And now since I used greater than and not greater than or equal to, there is a case where we could have two components that are the same or all three that are the same, in which case you would not know which component was the right component. So in that case, we'll just write an else to cover all other cases that we haven't caught, and we'll say unknown. All right, so that's pretty much all I want to cover as far as the code goes. So we'll turn on my camera here, and I'll show you what it looks like. Okay, what I want to do is, here's the robot. I wouldn't, yeah, this is very scary looking. One of the students at the school had built it, and they did it in a very in a hurry. So it's not the prettiest looking wire hookup, but basically all the pins are the same. Here's my color sensor pins. I have 0, 1, 2, 3, as stated in my code when I created my pinouts, which actually I'm just realizing now I set them all to 0. So let me change that. And I have them to 0, 1, 2, 3, and 4. So that's these pins here. 0, 1, 2, 3, and 4. This is the output. And those are all for this color sensor here. Okay, and this is what the color sensor looks like. You might, sometimes they have a little lens here, but they all pretty much look the same. And what I'm going to do is, just to show you that this is compatible with the Arduino code, or Arduino IDE. I just don't like writing in the Arduino IDE. So I'll copy and paste all that code in there. Change my board. This is a TNC32. Make sure I have my, oh, I don't have my hooked up here. Okay. Port, TNT port. And then make sure I have my programmer set because I was using the Pololu robot, which requires a different programmer. All right, verify that this code compiles. I'm not going to bother saving it. Okay, and it did compile. It opened up my Teensy loader. I'm using a Teensy here. It would work with an Arduino, same thing. Okay, so I'm going to upload it using the Arduino IDE, and then I will show you the serial monitor. Cancel again. Okay, done uploading. So I'll put serial monitor. Okay, so you can see if I hover over the red here, it's actually not showing red. Oh, I made a mistake in my code. So basically, I just want to cover this. I like to show the code as I'm writing it in real time because I'm not perfect. Nobody's perfect. I'm going to make mistakes, and so this way you might see something that you make a mistake, the same thing, and you could catch this. So I'm looking at the values, doing kind of the same thing that I've designed my code to do in my head. And what I thought my code was supposed to do is to look to see if intensity of red was the lowest. However, which it is, I have 4, 11, and 8. So red is the lowest. However, it's telling me green, but green is the highest. Well, now that I think back at my code, I was actually looking at the wrong comparison. So I should have been looking at RGB red is less than, because remember, the higher the frequency, the higher the intensity of light. So when I'm reading red, I'm going to see a higher frequency of red, which is going to make this high point a smaller number because it's a faster frequency. So I'm actually looking for the red to be the lowest, and in this case for the green to be the lowest, and for blue to be the lowest. And I probably should have done this in the Arduino IDE since that's where I'm uploading it from, but I'll just repaste that in there. Hit upload, cancel. Again, sometimes the Teensy likes to be active in order to actually work. Okay, so now if I hover over the red, it's seeing red. Hover over the green. Yep, I'm seeing green. And then blue. And now I'm pretty close. It starts to get a little dicey once you pull it away from the paper. Blues seems to be working pretty well. But green, you can see here, I'm moving over to the green, and it's seeing as red until I get about an inch from the paper, and now it's detecting pretty well. And then red's actually working pretty far away. So green's the only one that's a little bit iffy, and that might actually be explained if we looked at our overlaps here. Yeah, see, green's in the middle, so it's kind of overlapping. There's a much smaller range for green than there is for blue and for red. Okay, so that's pretty much it for the writing of your own code for an RGB sensor. And also, if you're not using a paper detecting an object's color, if you're using like a light, then that's going to be much easier to detect from a far distance. So if I shine a laser or a flashlight into this, like a red flashlight or a blue flashlight, I'm going to be able to detect from much farther away because I'm actually directing the photons into the sensor, as opposed to this way, where these LEDs are casting light, reflecting off the paper, and then having to bounce back. So the softer the material, the more absorbent it's going to be of photons, and therefore you're going to get less reflectance, and you're going to have to be much closer for softer, less reflective materials. Next step is, and you can leave here or not. The next step is to use the library that I did find on the internet, and that is, so if I just looked up TCS230, and this is the only one I found. It's the first one that comes up by Magic Designs. There is some documentation here explaining somewhat how to use it. There's even more documentation if you actually look at the source code files. Oh, sorry, maybe it's the header file. Yeah, so there's a whole lot of documentation in here. Coming back to my IDE, this one I am only going to use this because I have the ability to import libraries automatically, and I don't need to have them imported into Arduino, which I don't have them locally, so I won't be able to use my Arduino IDE for this. But I already have it set up because I didn't want to have to walk through. I'm just using the example that I found from the library. Color sensor library. We'll check out this example. Okay. So this is the example that I was mentioning. It's just the basic example. The one thing I found a little confusing is it doesn't tell you specifically how to set up S0 and S1. By default, it's assuming that you took control of that, because it has multiple constructors to select. So you can select, if I look at this, okay, so you can call the constructor that only requires you to have S2, S3, S2, S3 OE, S2, S3, S0, S1, and then all of those plus OE. So there's a couple different constructors. The example by default only had S2, S3, and OE. And I wanted it to control the frequency scaling. So what I did was I included the S0 and S1 as well. So if you don't do this, then you're required to control the S0 and S1. But if you supply this, then it will set the frequency for you when you call the begin. Okay, and the other thing that I wanted to mention was that it's a little confusing as far as the color sensor output. There's no mention of the color sensor output here because you have to pick a specific pin based on the board that you're using. Okay, and I can't remember exactly where it is, but let's do teensy freak count. I know it's Paul. Okay, I think this is it. Yes. Okay, so if you come to this page on the PJRC website, which is the website for the Teensy, it explains because the library is using this frequency count instead of using the pulse in. So he's using this frequency count library, and in order to use this library, you need to use one specific pin depending on the board you're using. So if you're using Teensy 3.5 or 3.6, it's going to be pin 13. 3.1, 3.0, or 3.2, that's the one that I'm using because I'm using a 3.2. That's going to be pin 13 as well. So basically, if you're using any of the more frequent boards from Teensy, it's going to be pin 13. Arduino Uno is going to be pin 5. The Leonardo is 12, the Mega is 47, and the Sanguino is 1. So what I have to do here is I have to change, because I have it hooked up to pin 4, I need to change this over to pin 13 on the Teensy 3.2, which 13 is always easy to find. It's the top left corner of the board. Okay, so I've done that. And now I will go back to my example, and then I will upload this. So pi run, target upload. Okay, and I think I'm all set. All right, that should have uploaded. All right, so it's saying calibrator example, reading value for black calibration. So what it wants you to do is, the nice thing about this library is it uses a calibration. So it gives you much better readings than if you were to write your own code for this. So it wants you to shine something on something black. I don't really, I mean, I guess I have this, but I just covered up the sensor. And then so you just, any letter, type it in. Okay, now it's looking for white. I'll just use this. It's not the whitest thing in the world, but it's white enough. So I'll try that. And then anytime you want to take a reading, you just push another key. So I'll put it over the red, hit a key, and it's telling me RGB is very, very predominantly red. So you can see this gives you a very, very good reading, and I'm pretty sure they scale the reading between 0 and 255. So it's pretty positive that this is a red component. And then green, we will do this. Any letter. Okay, so green. Again, it's still kind of iffy here. I mean, I was having some issues with the green with mine because of that narrow reflectance range. Um, but it's almost twice as positive. So you have around a value of 50 and around a value of 100 for your green component. So I mean, it's pretty sure that it's green. And then likewise, we'll go to blue. Hit that again, and then blue is almost twice as much as green. So we're pretty positive that it's green. But red was, I mean, red was definite. There was no distinguishing or no confusing it with anything else. Red was over twice as much as any other component. Now, what I'm curious is I was getting erroneous values at around an inch away. So let me put it about an inch away and see what I get. Yeah, it's still pretty positive. It's green. I mean, it's 64 versus 45. So let me go about look about 2 inches away. And we'll try that again. Yeah, it's still pretty positive. So you can see there is a benefit to using the library. The library uses the calibration and it incorporates a lot of extra code for you. So if you need that added benefit of having the good readings, then definitely try to use the library. If you're new, it might be a little more difficult, and so it might be easier just to kind of roll your own. But I hope this was helpful. Let me know if I missed anything or if you want me to clarify anything. And I hope to have another video soon on a self-balancing robot. But until then, again, hope you enjoyed and have a good one.
Hey everyone, thanks for watching. If you like this video and you want to see more like it, give me a thumbs up. And don't forget to subscribe.